Okay, so this is a follow-up video on physical and chemical change, where we introduced the concept of chemical reactions. In that video, we differentiated between changes in matter. We talked about two types of changes. We have physical changes and chemical changes. And now just going deeper into um, chemical changes that normally involved writing chemical equations. And those chemical equations that we write and need to know how to write requires us to balance them. And that's what we're going to talk about today, balancing chemical equations, right? This is aimed at grade 10 physical sciences learners that are doing CAPS, right? Awesome. Let's go to the next slide. So we're going to talk about how do we represent chemical change in written form or in symbolic form. So we represent chemical change by writing a chemical equation, and this is what we refer to as a chemical equations. A chemical equation where on the left hand side you have your reactants, right? Separated by this arrow over here, you just draw a normal arrow, and then on the right hand side you have your products. So the reactants are the stuff that you have. So let's say you go into a lab, you find the liquid there, maybe this is liquid A, and now you see that you're combining it with some liquid that maybe was in here. We call this liquid B or chemical B. Let me not say a liquid, let me say chemical B. When you add these two together, after the reaction has taken place, and we denote that the reaction has taken place by drawing that arrow over there, you form AB, a completely different compound than the ones that you started with. So this is how you would normally write it. Your reactants, like I said, are written on the left hand side. Your products are written on the right hand side, typically written on the right hand side. And then now there is your arrow over there to show the change that is taking place, right? Another important thing, but we'll talk about it later. If your reaction requires heat, you'll draw a small triangle there to show that your reaction requires heat. Maybe to add together these two things you need heat, then you draw it over there. But we'll talk about that later. Okay. So as I've mentioned, when we represent chemical change, we write what is we call a chemical equation. And that chemical equation has to be balanced. And we balance it by normally adding, you first check and then you add this digits there, these numbers in front of your compounds or your elements. And we call them coefficients. So this is 4 is a coefficient of A, 2 is a coefficient of both A and B. So that's very important for you to understand that 2 is a coefficient for both A and B. So this equation that you've written here, this chemical equation that you've written here is balanced. And how do we know that it's balanced? So you say, okay, let me write, I have two types of atoms that are taking place. I have atom A and atom B, right? And then we're going to count from the left and the right hand side. So on the left hand side, how many species of A do we have? If there's a 4 in front of the A, it means there are 4 species of A. So you write 4. And then you go to the right hand side and you say how many species of A do we have? You see we have a coefficient 2 there. But also we have this small 2, it's a subscript. So that means it's 2, this 2, the coefficient multiplied by this 2. So 2 multiplied by 2 is 4. So in a sense, we have 4 species also on this side. Because how you would normally write this, let's say if this thing has a small letter 2 there, you know that it's B that is bonded to another B. So in actual fact, there's 2 B's. And even here we have A that is bonded to an A which is bonded to a B, right? Maybe we have something like this. This is just an assumption. So you have, oh no, that was supposed to be A. Oof, it's very difficult to write with this thing. So you have two A's that are joined to B, right? And then we go again, we count the number of B's on the left hand side. So we say because there's a small letter there, 2, it means there is 2 B's. If it was 3, we'd say there is 3 B's. On the side, there's a B, but then because of this coefficient, it means it is 2 B's. So it is 2. So we will say this type of equation, chemical equation over here, is balanced because the same amount of species on the left hand side is the number of atoms on the left hand side is equal to number of atoms on the right hand side for each species or element, let me say that, right? So let's move on forward. So again, before we start balancing chemical equations, it's important for us to understand different states. So remember, I think in term 1 we spoke about 3 states. In your school, at school, you must have talked about 3 states of matter. So we have solid, we have a gaseous form, we have a liquid form, right? And in a chemical equation, G, you have to write a G in brackets if you are required to for a compound that is in a gas form or a molecule. L for a chemical that is in a liquid form. S for a compound that is in a solid form, right? And AQ there for an aqueous water solution. So you have to know those things. And as I've mentioned, sometimes on top of that arrow that is separating our reactants and products, you write on top of it this Greek delta, this triangle, which is a Greek letter delta, right? And it's placed just above the arrow to show that heat is required. And in this reaction, this compound here requires heat to break into this compound plus this compound, right? And you can already tell because we've spoken about this in the last video where we said this would be an example of a decomposition reaction. This will be an example of a decomposition reaction because this this ammonium chloride is broken up into ammonia and hydrochloric acid, right? So let's look at a few examples. So normally, to show state symbols, you would find equation or chemical equations like this one, where you have water to show that it's in a solid form, they put the S in parentheses or in a brackets, right? The arrow and then the product, it's still the same water that is now in a gas form. So this is a physical reaction because the only thing that has changed is the form. So the state moved from being solid to now being gas, maybe from being ice to now being steam, or yeah. And then here even we have calcium carbonate, it's in a solid form. Here we have calcium oxide, it's in a solid form. We have carbon dioxide, which is in a gaseous form, right? So that is how you typically show state symbols. It's very important for you to understand this because sometimes the question may say, please balance and also show state symbols. If you're not required to, it's not necessary, but sometimes you are required to add them. So it's very important to know how to show them, right? And now, before we start actually balancing chemical equations, so before we start, we need to understand the law that governs this chemical reaction that tells us that they need to be balanced, and that is the conservation of atoms and mass in reactions. And you will explain what you mean when we say atoms must be conserved or the mass in a chemical reaction must be conserved. So you must understand that. So the first thing it means that the total mass of all the substances taking place in the reaction must remain the same, and we say it's the conservation of mass. So let's take an easy chemical reaction where iron reacts with sulfur to form iron sulfide, right? And then to prove that the total mass for the reaction remains the same, that will mean that on the left hand side before the reaction is taken place, the total mass on the left hand side before the reaction takes place is equals to the total mass on the right hand side after the reaction has taken place, right? So to do that, we use the molar mass of sulfur, which is 32.00066. So I've just rounded off to 2 decimal places, right? So it's 0.7, and also the consider the molar mass of iron, which is 55.84, and I rounded it off to 85, right? Good. So then we would say, okay, on this side we have the molar mass of iron, which is 87.92. No, I'm lying. The molar mass of iron, which is 55.85, added plus the molar mass of sulfur, and it will give us 87.92. But even on this side, if you compound this like this, you will know that it's 55.85 plus, not multiply, plus 32.07 if it's like this, right? And then you still get 87.92. So that means that the total mass is conserved. So the total mass of the substances taking place in the reaction remained the same. And this means that our equation is actually balanced. So that's one way to check if your equation is balanced. Another important way that we will use primarily to check if our equation is balanced is that also the conservation of, we talked about the conservation of mass and atoms, right, in the reaction. So for this part means that the total number of atoms in the reaction remains the same. That is, the total number of the atoms taking place in the reaction before and after the reaction must remain the same. What do we mean? So what you're going to do is that you're going to just write, for this, going to write iron, and you also write sulfur, and then you write these dashes or draw them. Then you check on the left hand side, how many iron atoms do you have? And we know that we have one that I've written over here. Then you go on the right hand side, how many ions do you have? You just have one. On the left hand side, how many sulfur atoms do you have? You just have one. On this, and on the right hand side, how many sulfur atoms do you have? It's just one. So your equation is balanced. And that is basically what we're going to be doing to check and to balance chemical equations from now on. We'll just look at a few examples that you need to know in terms of balancing these chemical equations, right? So let's say, for an example, we're given a question, and they said in the question, ammonia reacts with oxygen to form, ammonia there reacts with oxygen to form nitrogen monoxide and water. So it's very important for you to know how to write chemical compounds in the symbols, right? If you're given a sentence, you need to know the formula for ammonia, for oxygen, for nitrogen monoxide, for H2O. This you should have done earlier this year. If you don't know how to do it, just revisit some of your term 1 work, and then before you can actually come to this part of balancing them, right? And then they say we need to write a balanced chemical equation for the reaction. And the first thing you need to do is to check, or in this case is to write the chemical reaction in its symbolic form, right? So you know this is ammonia NH3 plus oxygen, the molecule O2, before the reaction, right? And then after the reaction, nitrogen monoxide and O was formed plus water, which we know to be H2O, right? Then you just write N for nitrogen, H for hydrogen, and O for oxygen, right? And then we check on the left hand side, how many nitrogen atoms do you have? So there's the nitrogen atom, there's only one, so you write that one there. And on the right hand side, how many nitrogen atoms do you have? You see just this nitrogen atom, and then you write one. So they are balanced, the nitrogens. And you go for hydrogen, on this side, the left hand side, how many do we have? We have, you said H, because it has this small letter there, 3, it means there's 3 hydrogens. It's written there. And then on this side, you see it's H2. So we have 2 hydrogens. They are not balanced. And we proceed further. Before we can balance, we check how many oxygens do you have on this side. We have 2. And then on this side, it's 1 plus this 2 over there. So it is 2 even on this side. So our equation is not balanced. We need to balance it. And if we check, we say, okay, what is it that we need to balance? We see that we need to balance the number of hydrogens, right? Because the nitrogens and the oxygens are balanced so far. So we need to balance the hydrogens. So if we have 3 on this side and we have 2 on that side and we want them to be the same, it means that we can just multiply 3 by 2, which will give me 6, and multiply 2 by 3, which will give me 6, right? So to do that, I just put 3 multiplied by 2. I hope that's what I said. So you multiply this 2 by 3 and 3 by 2 and then 2 multiplied by 3. This means I'll take this 2 and put it here as a coefficient, and then on this side I'll take this 3 and put it here as a coefficient, right? And after you do that, you have to check. So now you have that equation over there. Let me just do this. Okay, now you have that equation over there where you have 2NH3 plus oxygen, nitrogen monoxide, and water, right? Get my pen, and then you check again. So you, because of these 2 now, you say that I have 2 nitrogens on this side, and on the other side I have 1 nitrogen, right? So it's not balanced. And then I have hydrogens. I have 2 times this 3, which is 6. Hydrogen 3 times it is 2, it's going to give me 6, right? And then for my oxygens, I have 2 on this side, O2, and I have 4 on that side because of this oxygen plus 3. This 3 oxygens will give us 4, right? So now I want to balance my nitrogen. When I balance my nitrogen, I can just put a 2 here. If I put a 2 here, this is essentially what you get. And after you do that, you must check. So you check left hand side, I have 2 nitrogens. This 2. On the right hand side, I also have 2 nitrogens. There you are. Hydrogens, we know it's 2 times 3, which is 6. On this side, it's 3 times 2, which is 6, right? So there you are, you are balanced. Oxygens, you say you have 2. And then on this side, because of this 2, it's 2 plus now 3. So it's 2. So it's 2 oxygens here. And then now it's 3 oxygens. So 2 plus 3 is 5. So now you say, okay, how do I balance the number of what you call the number of oxygens? So you may say, okay, I can multiply the 2 by 5. If you multiply here by 5, meaning I'll put a coefficient of 5 over there maybe, right? And then, so that would be like 10. 5 times 2 is 10. And on this side, I can just say, okay, if I put a 4 over there, it means that we have 4 oxygens. And I put a 6 over there, it means we have 6 oxygen, and 6 plus 4 will give us 10. So let's see what that equation will actually look like. So this is now what our equation will look like, right? So we've put the 5 as well as the 4 and the 6. So after balancing all of that, we now, the oxygens, we now need to check. We check on the left hand side, how many nitrogens do we have? We have 2 nitrogens, right? And then on the other side, we have now 4. So you see the nitrogens now are not balanced. And then we check the hydrogens of 2 times 3, which is 6. But now because of the 6 here, the number of hydrogens on the right hand side has increased with 6 times 2, which is 12. But the oxygens, if you check, it's 5 times 2, they are balanced. And as well, it's 4 plus 6, which is now 10. They are balanced. So we need to balance. So let us now balance the nitrogen and check. So to balance the nitrogen, you can multiply this by 2. Multiply by 2, then we'll get 4. Meaning we'll remove this 2 over there and replace it with a 4, right? Then we check, and then when we check, we say, oh, okay, nitrogen on this side, it's 4 nitrogens. On the other side, it's also 4 nitrogens, right? Hydrogens, it's now 4 times 3, and you know that that is 12, right? So they are now balanced. And then on this side, it's again 6 times 2, which is 12, and the number of oxygens is 5 times 2, it's 10. It's 4 plus 6, this 4 plus 6 is 10. So now your equation is actually balanced. I hope that is clear. Now we can look at another question. So question 2, it says to us, write a balanced chemical equation for the following reaction, where you have Mg magnesium reacting with HCl, that's hydrochloric acid, to give us magnesium chloride plus hydrogen. So hydrogen, they will be released as a gas, right? The first thing you do is to check whether the given equation is balanced or not. And then if it's not balanced, then you can proceed to balancing it, right? You write again your atom, you have magnesium, you have hydrogen, and then you have chloride, right? So then you check, you say, okay, on the left hand side, how many magnesium atoms do you have? We have just one, this one, then you write it over there, okay? And then on the right hand side, you check how many magnesiums do you have. You still have just one, so the magnesium atoms are balanced. Then you check, okay, on this side, how many H's do you have, the hydrogens. You say, okay, on this side I have one hydrogen, and then on this side you go, oh, because it's H with a subscript there, 2, it means that there's 2 hydrogens. So you write 2, say definitely the hydrogens are not balanced. You do the same thing for the chloride or chlorine, and then you see how many Cl do you have. You have 2, and then on this side how many you have, it's Cl2, right? So that means it's 2 chlorine atoms on this side, so they're also not balanced. So how do you then balance it? So you check, okay, let me try first to balance the hydrogen, and that would mean that I have to multiply this one there. Get a pen. So multiply 1 by 2. That would mean I need to take this coefficient of 2 and just write it here. And if I do that, I will get this equation, the bottom equation, right? And then after you get it, so you have Mg plus 2HCl giving us MgCl2 plus H2. After you balance the hydrogen, check before you proceed to the chlorine, because sometimes when you balance hydrogen, maybe the chlorine also balance. So it's always important, balance one thing, check, balance another, then check. It's that kind of process, right? Okay, so then we check how many magnesium atoms do we have on this side. It's still 1. On this side, it's still just the 1. And then for the H hydrogen, you see it's 2H, so you have 2 on this side, sorry, and then on the other side you also have H2, so it's 2. For your chlorine, so on this side you check, it's 2HCl. Remember, this 2 is for both the hydrogen and the chlorine, so it's 2 chlorine. You see, even on this side, Cl2 means it's 2, the chlorine bonded to a chlorine, so it's also 2 chlorine atoms. So if you check, our equation is actually balanced. So this one was a bit straightforward than the one that we did previously, right? Hope that makes sense. Now let us look at another example. So this is question 3 there. It's question 3, it's not question 2. So you say, write a balanced chemical equation for the following reaction. So this is the reaction that you given. CH4, this is methane, plus oxygen to give us CO2, you know this is carbon dioxide, plus H2O, which is water. So this is an example of what you call a combustion reaction. And when you take this, this is an example of an alkane. You do this in grade 12. When it combusts, it reacts with oxygen, water, and carbon dioxide, plus energy is released. Hence, you've written CO2 plus H2O. Just something interesting I thought I should mention. So, first thing, we have to check whether our equation is balanced or not. And then if it's not balanced, then we balance it, right? You check the carbon, you check, okay, on this side of the equation, on the left hand side, how many carbons do I have? You see just one, and then you write it one. Then you go on this side, how many carbons do you have? It's just one. Hydrogens, you check on this, it's H4, meaning it's 4 hydrogens on this left hand side. Then you go on the other side, you say it's H2, so it's 2, so that part is not balanced. Already telling us that our equation is actually not balanced. Then you check for the oxygen, it's O2, so it means there's 2 oxygens, and it's O2 plus the O here, meaning it's 3 oxygens. So now we need to balance. And how do we actually balance? So you start balancing the hydrogen. So okay, to balance the hydrogen, let me get a pen. To balance the hydrogen, I can just multiply by 2. And if I multiply by 2, meaning I'll put a coefficient of 2 over here, and when you do that, you get this reaction over there. So you see I've put the 2 there, so we have 2H2O now, right? And then after you do that, you check whether what the carbon is still 1 and the carbon is still 1 on this side, right? The hydrogen is 4 on the left hand side. Now 2 multiplied by H2 will give us 4. It's 2 multiplied by 2 will give us 4. So you have hydrogen, so those are balanced. The one thing that is not balanced is the oxygen, because on this side you have O2, meaning 2, and then on the right hand side you have O2 plus now this 2. So this 2 is for both H2 and the O. So it's 2 plus 2, which will give us 4. How do we then balance the oxygen to make sure it's 4? So it seems like, okay, you can just multiply on this side with 2. So 2 times 2 will give us 4. It means that I'll put 2 here as a coefficient. And now let us look what our equation will actually look like. So our equation will look like this. Now we've added the coefficient of 2. Then you check again. So check the number of carbons. You must get 1 on this side and 1 on this side, right? The number of hydrogens, you must get 4. Even on this side, 2 times 2 give us 4. Oxygens, it's 2 times 2, which should give us 4. And then it's this O2, which is 2, plus this 2 here for oxygen will give us 4. And our equation is balanced. Hope that was clear. Let us look at another example, right? So you have to write another balanced chemical equation for the reaction that was given. So this is C6H2O6. This is glucose. This is sugar. And when you also it reacts with the oxygen, carbon dioxide will be released as well as water. Another example of combustion, right? And remember our first step in any, because sometimes we will be given a balanced chemical equation. So you have to first check whether it's balanced or not. So the number of carbons we see is C6 on this side. So I'm trying to get a pen. So it's C6 on this side, meaning it's 6 carbons, and then on this side it's just the 1. You see it's 1. Check the hydrogen on this side, it's 12. So it's 12 hydrogens, and on this side it's just H2, meaning it's 2 hydrogens. On this side then we have O6 plus this one. So when it's 6 plus 2 would now give us 8. For the oxygen it's the 6 plus this 2, which will give us 8. On this side you say it's O2 plus this O1 over there. So it's just 3. So our equation is clearly not balanced, and now we need to balance it. How do we do that? So we start first off by balancing the carbon. So you say, okay, to balance the carbon, I can just simply multiply by 6. Meaning I'll need to put a 6 here in front of the carbon. If you put a 6 here, and when you do that, this is the equation that you get. So you have 6 carbon dioxide, right? Then after that, before you go to balancing the hydrogens, you now check. You say the number of carbons on this side, it's 6. Even now on this side, 6C, it's 6. The number of hydrogen on this side is still 12. And the number of hydrogens on this side, because it's H2, it's still 2. The number of oxygen is still the O6 plus O2, which will then give us 8, right? And then on this side, now we have 6 times 2. So the 6 here, multiply by this small letter 2 there for the oxygen, which will give us 12. Plus still this oxygen over there, which is now 13, right? And now we need to balance. So the next thing we need to do is to balance the hydrogens. Okay, how do we balance the hydrogens? So you say, okay, to balance the hydrogen, because I have 12 and I have 2 this side, I can just multiply maybe by 6. And meaning you put a 6 over there. And now we check what will that equation look like after we put the 6 there. And we realize, okay, if I put the 6, this is now we'll have 6H2O, right? And then after that, you check. So you say the number of carbons, 6. On this side, it's still 6 as well. On both sides, it's 6. Hydrogen, we still have 12 on the left-hand side. We have 12 on the right-hand side now. So we'll have the 6 carbon atoms there. And then we'll have the 6. No, I'm talking about hydrogen. That was a mistake. So I have the 6 times 2, right? Which will give us 12. Now we go to the oxygens. It's still this 0.06 O2, which will give us 8. And now we go to the oxygen. The number of oxygen says it's 6 times 2, which is 12, plus the 1 oxygen there, which will give us, no, I'm lying. So it's 6 times 2, which is 12, plus 6 times the O there, which is 6. So it's 12 plus 6, which will now give me 18. Do you see now? Right? So now I have 18 oxygens on this side, and on that side I have 8. How do I balance them? You can say, oh, okay, if I have 6 there and I have 2, I can just put a 6 over there. So then I have 6 times 2, which is 12, plus this 6, which will give me 18. So I do just that, and this is what you will get, right? So you have the O6 plus the 6O2. So 6 multiplied by this 2 will give us 12, plus this 6 is now 18. And that's your equation. And if you check, you'll see that on the left hand side you have 6 carbons. On the right you also have 6 carbons. On the left hand side you have 12 hydrogens. On this side you also have 12, 6 times 2 there. And on this side you have 18, which is the O6. So it's 6 plus 6 times 2, that is going to give us 18. So you see the importance of knowing your basic arithmetic, multiplying, adding, right? And then even on this side you have 6 times 2 oxygen, which will give us 12, plus the 6 here, which will give us 18. Okay, let us now look at another example. I think this is the last example that we will be looking at. So we have to write a balanced chemical equation for the following reaction. So you're given, they say zinc reacts with HCl, hydrochloric acid, to form zinc chloride plus hydrogen. So you must recognize that this is almost the same as when magnesium reacted with HCl. You see, it formed, and then it formed magnesium chloride. But the important thing is that the release of that hydrogen gas. Actually, a very cool experiment you can do with a balloon when you collect this gas and then you burn it and it kind of pops, right? But that's not important right now. So the first important thing is that we must balance. So you check on the left hand side how many zincs we have. We have just this one, right? So you write it. On the other side you also have one zinc atom. Cl, the chlorine, on this side you have one. On the other side you have Cl2. It means that you have 2, right? Hydrogen, you have 1 here on the left hand side, and on the right hand side you have 2. So we need to balance. And how do we balance? You balance, you can say, okay, I can just multiply chlorine by 2. So you say multiply by 2, meaning that you write 2 over there, and then this is the type of equation you will get with the 2. So now you have 2HCl. And before you can go to trying to proceed to balance the H's, first check. So you check, say zinc is still 1, zinc on this side is still 1, right? On both sides it's 1 1, left side and right side, right? You check your chlorine, you say Cl on this side because it's now 2. This 2 is for both the hydrogen and the chlorine, so we have 2Cl, right? And on this side you have Cl2, it's balanced. Check the hydrogen, we have now 2 H's on the left hand side, even on the right hand side, because it's H2, you have 2. So the equation is actually balanced. You are done. Awesome. So let us say the next question required us to also include the state. So to show what is a metal, what is a solid, what is a liquid, what is what, right? So this is what you would do. You would write your balanced chemical equation over there, and then zinc, we know it's a solid, it's a metal. HCl, hydrochloric acid, is in an aqueous solution, right? And then after the reaction, it will form zinc chloride. It's actually a solid that you will get, plus H2, which is in a gaseous form. So it's very important for you to know in which state is your material, right? So you must know that periodic table, you must know these compounds, especially the ones that you will use frequently. And I know maybe this might seem a bit tedious. It feels like it's a trial and error. The only way to get good at balancing this chemical equation is to keep practicing. Practice up until you get them. You are able to see what is it, which coefficient you need to add. That's really the only way you're gonna be able to get good at balancing these chemical equations. Because sometimes you'll be given a question. You'll see when we do qualitative aspects of chemical change, right? When we start counting, when we start calculating volume, molar mass, number of moles. When you're given any chemical reaction during that time, you will need to know how to balance it. Because if you don't balance it, or it's not balanced, you'll get the wrong values and then you've lost marks, right? So it's important for you to learn how to balance, and the only way to do that is to just practice and practice. Take all of these examples that we've done today, see if you can do them on your own. I'm sure on your textbook find more examples, right? So now this question is from an exam paper or a test paper. There's this wonderful app, grade 10 physical sciences. I think you can find it in the Play Store or the Huawei Store. Then you can download it on your phone. It has some nice practice questions, right? So I just took one from there, and then we can just do it together, right? Before we finish this tutorial. So this is the question. So you're given a word, a sentence equation. So they say that iron plus oxygen react to form iron 3. So this Roman figure 3 in parenthesis, in brackets, parenthesis, means iron 3 oxide. And the question says, write down a balanced chemical equation, show the phases of all reactants and products. So you see the number of skills that you need to have for you to answer this question. I think it was 4 marks if I'm not mistaken. You need a number of skills. First of all, you need to write these elements in their symbols, and you also need to know when you react and you form a compound, what happens, right? So the first thing we need to do is to write this equation in a symbol form. So we do just that. Okay, we say, okay, we know iron is Fe, we know oxygen is O2, and then it reacts, it forms iron oxide. So because they said it forms iron 3, it means the cation Fe3 plus will react with your anion O2 minus there, you see? And it's almost like you take this 3, you put it there as a cross, you cross, I don't want to say cross multiplication because that would be just wrong, but it's almost like you take this 3, move it there to form the compound, you take this 2, you put it there. So you have Fe2, this 2 there, and you have this 3 there, and then you will have formed your iron 3 oxide, right? So now we've written the equation. Our task now is to balance it and to see whether, now to check whether it's balanced or not. That was our first thing. So we write the same thing we've done, which is Fe. On this side, to check on the left hand side is 1 iron, right? I've spoken for long now. I'm getting a bit tired. So it's 1 iron. On the other side, on the right hand side, it's Fe2. So it means the subscript is 2 ions. So you write the 2 there. You check the oxygens on this side, you say it's 2 because it's O2. On this side, it's O3. It means it's 3 oxygens. So what do we need to do? We need to balance by putting coefficients somewhere. So you say, okay, let me first start by balancing the number of ions. So to do that, I can just multiply by 2, right? That means I'll put 2 over there, and this is what you will get: 2Fe plus O2 plus Fe2O3. Now we need to check again, is it balanced before we can proceed? We say, okay, on the left hand side, now I have 2 ions, 2Fe. On this side, I also have 2 ions, so they are balanced. That's good. Oxygens, I have O2. On the other side, I have O3. They are not balanced. So how do we balance them? So you can say, okay, the one way to balance this would be to say, okay, I can multiply here by 3, meaning I'll put a coefficient of 3, and this side I can multiply by 2. I mean, I'll put a coefficient of 2 over there. So 3 times 2 is 6, 3 times 2 is 6, right? And then after you do that, you now check. So you say, okay, Fe on this side, it's 2Fe, it's just 2. On the other side, Fe, it's, because now this coefficient is 2 multiplied by this subscript 2 there. It's 2 times 2 should give us 4. So the number of ions is now, it's no longer balanced. And let's check the oxygens. We say it's 3 times the 2, it's 6. And then on the side, it's 2 times the 3, it's 6. So our next step is to balance the ion. So how do we do that? So I would say, okay, I need to have, let me get a pen. So I need to have there's 4 ions on this side. I need to have 4. I can just remove this 2 there. So it's almost like you multiply by 2. 2 multiplied by 2 give us 4. So you put 4 there in front of the Fe, and this is what you will essentially get. So you get 4Fe plus 3O2 plus 2F2O3, right? Check the number of atoms of iron. 4 on this side. You must check with me. It's 4 on this side. On this side, it's 2 times 2, it's 4. The number of oxygen is 6. 3 times 2, it's 6. And then the oxygens, it's 2 times 3, it's 6. So your equation is balanced. We are really happy with that. But we're not done, remember. So we've balanced the equation. The question required us to add the states. So you know iron is a metal. It's a transition metal. Oxygen, it's a gas. The iron reacts with the oxygen in the atmosphere to form iron 3 oxide. It's that brownish layer that you form on your steel something. If you put it outside, you'll see that it reacts with the oxygen. It forms this it doesn't appear shiny anyway, it appears brownish, right? And you form that iron 3 oxide. Rust is an example of rusting, right? So this actually brings us to the end of our tutorial. I hope you learned something, and I hope everything was clear. If not, you can put your questions in the comment, and I'll try to attend to them. Thank you so much.